All right, so we're recording now. All right, so for the sampling distribution, you're saying instead of taking a sample of one, we're gonna take a sample of n many. But instead of taking like n many and looking at the individual score, what we do, we're gonna look at the average of the score. So if you look at this drawing, that's what this drawing is trying to convey. So what we're doing, we're sampling from the population and we're getting a sample of n many, and then we're recording what the mean is. So we say the mean is for the first one, some value, and then we record for the second value. And what's actually happening here, you should be getting a more accurate data set. You could kind of think about it, instead of sampling just one data set, you're sampling n many data sets. So you're gonna trust the sample of n many versus a sample of just one. Any question in regard to that so far? And whenever we're drawing from the population, we're drawing with replacement. So technically we could pick the same number again. So anytime we're drawing from this with the sampling distribution, it is technically possible for us to draw the same number. All right, so let's get to the formula. So for the formula, we're gonna have something called mu of x bar and sigma of x bar. So mu of x bar, if you look at it, is equal to the mean, because you're saying it doesn't matter how big of a sample size we have, the mean of the sampling distribution will be the same as the mean of a sample of one, because if the mean for sample of one, it will still be the mean for sample of n many. So for mu of x bar, it is saying it's not changing. But if you look at it where it says sigma of x bar, which is this one over here, it actually is saying that the standard deviation will change. Because if you look at it, it's saying that standard deviation of x bar is equal to standard deviation divided by square root of n. So if you look at that, it's saying like the bigger your sample size get, the smaller and smaller your standard deviation of x bar is gonna be. And another way to call it, they also called it the standard error of the mean. So for the standard deviation will actually change, because the bigger the sample size you get, the smaller and smaller your population standard deviation of x bar will be. All right. Any questions so far for those two formulas?
No.
All right. So once we go into class calc, if you remember for class calc, when we do normal distribution and it asks you for mean and sigma, so instead of giving mean and or mu and sigma, what we're gonna do, we're gonna give it mu of x bar and sigma of x bar. So it's not changing that much, but you do kind of want to put that in class calc. So instead of putting mu and sigma, you have to put mu of x bar, which is just mu, and you have to put sigma of x bar, which is just sigma divided by square root of n. All right, so let's scroll on down. All right, so let's do this one. So it said you write the population value. So the population value of 1357 on a slip of paper and put them in a box. Then you randomly choose 2 slips of paper with replacement. So for this one, it says find the mean and find the standard deviation of the population. So our population, or our n, is equal to 1, 3, 5, and 7. So what we want to do, we want to find mu of this, but we also want to find sigma of this. So to do that, we're going to do it in class calc. So let's go ahead and transfer over to class calc. That's not class calc. That's my other class. All right, so here goes class calc. So I'm gonna say A is equal to bracket 1, 3, 5, 7. And we're gonna go ahead and find the mean of this. So we'll say mean of A. All right, so if you look at the mean of A is 4. And remember, this is for the population because they're telling us the population is pretty much only have these 4 numbers of 1, 3, 5, and 7. Now we're gonna find standard deviation. And we'll say standard deviation of A. So if you remember, so since this is the population, your standard deviation is actually equal to the sigma where it says 2.236. So 2.236. All right. Everybody good with that so far? All right, cool.
Yes, sir.
So let's go back to my notes and let's do part. It says part C, but obviously it should be part B. All right. So let's do part B. So for part B, it said list all the possible outcome of size n is equal to 2 and calculate the mean of each sample. All right, so what we're gonna do, we're gonna say all the different ways that we could get a sample size of 2. So that means we're gonna randomly select 2 numbers. So we'll say data 1, data 2, all right, so we're going to list out all of the different ways that we could get a sample size of 2. And remember, we're doing this with replacement. So whenever we select a number, that means we could select that number again. So let's first start off with 1. So say the first number we select is 1. So I select 1, I put back 1, and then I could reselect 1 again. So this is one of the sample I could get. So I could get, first time I select the number, I could get a 1. The second time I select the number, I could get a 1 again. All right, so let's do 1 again. So let's say I select 1 in the first try. So in the second try, which number do you want to get?
5.
All right, cool, 5. All right, so that's the other sample. So let's say we do, first one we get 1 again, and then we could say we get 3. Then we could say we got 1 again, and then we get 7. All right, so those are all of the values that pretty much you start off with 1. So let's say now we start off with 3. So if I start off with 3, I could get 3, and I could get 1. Or I could start off with 3, and I could get 3. Or I could start off with 3, and I could get 5. And let me put data 8. I could get 3 and get 7. So those are all of the different ways I could get first 3 and then the other numbers. So let me do something. So say 9, 10, 11, 12, 13, 14, 15, and 16. All right. So now if you kind of see the pattern, which should be the next number that I could say that I start off with?
5.
Yeah, 5. So for 5, if I select 5 first, that means I could get 5, 1, or I could get 5, 3. I could get 5, 5, and lastly we could get 5 and 7. All right, so then the last one will be 7. So it'll be 7, comma 1. It'll be 7, comma 3. And we could get 7, comma, oops, forgot about 5. 5, and then we could get 7, comma 7. All right. And that's it for that one. So those are all of the different ways I could get a sample of 2 from this population. Everybody go on the sample size of 2?
Yeah.
Okay, so now we're gonna calculate the mean for each one of these. So if you remember, for the mean, what you have to do, you have to add both number and then divide by 2. So I'll do an example of one, but so say if we're calculating the mean for the first data set, you're gonna do 1 plus 1 divided by 2. 1 plus 1 divided by 2 is 2 divided by 2, which is 1. So the mean of data set 1 is 1. So let's do the mean of data set 2. So if I do 1 plus 5 divided by 2, you get 6 divided by 2, and you get 3. All right, so that's data set 2. So let's do the mean of the third data set. So we'll say mean of 3 is 1 plus 3 over 2. You get 4 over 2, and you get 2. All right. So lastly, we're going to do data set 4. So we'll say the mean of 4 is equal to 1 plus 7 over 2. You get 8 over 2, and you get 4. All right, so let's go data set 5 now. So for data set 5, I'm going to skip the adding part, and I'm going to give you the answer. So that one should be mean of 2. This one should be mean of 3. This one should be mean of 4. This one over here should be mean of 5. All right, so let's do data set 9. So for data set 9, we get a mean of 3, mean of 4, mean of 5, mean of 6, mean of 4 again, mean of 5, mean of 6, and a mean of 7. So if we look at which number occur most often for the mean, what would, which number occurs the most often for the mean? Well, let's keep track of it. So we have 1, 2, 3, 4, 5, 6, 7. So how many times did 1 occur? Well,
1.
yeah, good. We got 1, 1. What about 2? How many times did 2 occur?
2 times.
Yeah, 2 times. Perfect. What about 3? How many times does 3 occur?
3 times.
Yeah, 3 times. What about 4?
4.
And what about 5?
2 times.
Yeah.
3
What about 6?
Twice.
Yeah. And what about 7?
Once.
Once.
Cool. All right. So what do you know? Which one's the number that occurs the most often?
4.
Yeah, 4. And if you go back, when we found our mean of the population, our mean of our population was actually 4. So that's why when we get the central, whenever we get our standard deviation, our mean, that's why the mean of X bar doesn't change, because it doesn't matter if we have a sample of 1 or a sample of 2 or a sample of 10, 20, your mean will always stay the same. But if you look at your standard deviation, for the standard deviation, that one will change. Because if you look at this sample size of n, you have a gap of 2 because it go 1, 3, 5, 7. But now if you look at our new sample, there is no gap because it goes from 1 to number 2 to number 3 to number 4 to number 5 to number 6 to number 7. So we are going to get more accuracy with this data set. So that's why whenever we increase the sample size, your mean will stay the same, but your standard deviation will actually get smaller and smaller depending how big your sample size is. All right, everybody good so far with that? All right, so let's do central limit theorem. So for the central limit theorem is essentially an idea that says that as our sample size increases, our distribution is going to become more and more symmetrical or more normal. So if you forgot what does normal mean that has this sort of shape. And it's important to have that shape because if it doesn't have that shape, then we won't be able to find the probability of event occurring. So that's why it's important that we kind of apply the central limit theorem, because the central limit theorem is saying as your sample size increases, it should become more and more symmetrical. So the rule of thumb is if your sample size is greater than or equal to 30, we could say our distribution is now normally distributed. So if you look at this drawing right here, does this drawing look like this one over here?
No.
Nope.
So we're gonna say this is non-normal. So that distribution right there is not normal. But what the central limit theorem said, if I keep sampling from that and keep sampling n many data sets, it should start getting more and more normal. So if you look at this one over here, what's happening, we're getting sample and that sample is contributing to these mean that we have in this population. So whenever our data set is non-normal, if our sample size is 30 or greater than 30, we could say that it's now approximately normal. So that's kind of going to be the thing that you want to look at. You want to look at the central limit theorem because if the problem doesn't tell you it's normally distributed, what you want to do, you want to check the central limit theorem and you see if n is greater than or equal to 30. So if n is greater than or equal to 30, you're going to say it's approximately normal. All right. Any question in regard to that so far? All right. All right, so here are the formulas again. So mu of x bar is equal to mu. If you want variance, pretty much is sigma squared divided by n, but 99% of the time, we're gonna be using this formula instead, because that's the formula for standard deviation or standard error, which is equal to sigma divided by square root of n. All right, so let's go on down. All right. So for this one, says the training heart rate of all 20-year-old athletes are normally distributed with a mean of 135 beat per minute and a standard deviation of 18 beat per minute. As shown in the following graph, the random sample of size 4 are drawn from the population and the mean of each of the samples is determined. Find the mean and the standard and the standard error of the mean and of the sampling distribution. Okay, so first thing before you start trying to do the problem, what you want to go ahead and do is just label everything. So you have to look at all of the number and you see what do they represent. So first thing we have 135, we have 18, and we have 4. So what we want to go ahead and do is just label those three things. So the 135, what is the 135? What does it represent?
The mean.
Oh, so the mean. So remember, there are two options that you could do for the mean. You could either say X bar or you could say mu. So you know it's X bar and they tell you they took a sample and from that sample we got 135. Or if they tell you the mean of all athletes are 135, then you say it's mu. So if you look at this, they don't tell you they took a sample and from the sample they got 135. They're kind of just giving you this information. So that's why I know this is mu. All right. What about the 18? What is the 18?
Standard deviation.
Perfect. And for this one, same thing. If you look at it, they're not telling me they got it from a sample. They're telling me pretty much this is the standard deviation for all 20-year-old athletes. So if you look right here, all. So that's sigma. And that's important because once we get to the lecture on Monday, we're not going to know sigma and there's going to be a different process that we do. So you kind of know that for this one, it's important that we do know that we have sigma. Because once we get to Monday, we're going to be going over what if we don't have sigma. All right, and lastly, what is 4?
Random sample size.
Sample size, so that's n. All right, so the last thing that's kind of important that they give us in this problem, if you look at it, it tells us we have a normally distributed. So we know our distribution is normal. All right. So if you look at it, since they told us that this has a normal distribution, we can actually go on and find the probability for this one, even though the sample size is small. But for this one, we don't have to really worry about that because they don't want us to find the probability. All we have to do is find mu of x bar and sigma of x bar. So remember, mu of x bar is equal to mu. So it is 135. If you look at sigma of x bar, the formula is sigma divided by square root of n. Sigma in this case is 18 divided by square root of n, which is 4. So if I do square root of 4, you get 2. So if you do 18 divided by 2, you get 9. And that's your standard error. So we found our mu of x bar and we found sigma of x bar. Any question in regard to that? All right.
No.
So let's try this next one. So it said the height of a fully grown white oak tree are normally distributed. So once again, we already know normally distributed with a mean of 90 feet and a standard deviation of 3.5 feet as shown in the graph below. A random sample of size 4 are drawn from the population and the mean of each sample is determined. Find the mean and the standard error of the mean of the sampling distribution. All right, so once again, we have 90, we have 3.5, and we have 4. So what we have to go ahead and do, we have to go ahead and label it. So what will 90 be?
Mean.
Mean, perfect. So yeah. What would 3.5 be?
Standard deviation.
Mhm.
And lastly, what will our sample size be? I already gave you sample size.
4.
All right, so we got mu, which is 90. We got sigma, which is 3.5. And we got n is equal to 4. So we're going to go ahead and find mu of x bar, sigma of x bar, and then we're done with that. So mu of x bar is equal to mu, which is equal to 90. All right, so that's it for that. Sigma of x bar is equal to sigma divided by square root of n, which is equal to 3.5 divided by 4. Don't forget the square root. So if I do 3.5 divided by square root of 4, you get 3.5 divided by 2, And then 3.5 divided by 2 give you some number, 1.5. Give you 1.75. And that's it for that second problem. Any question for that second problem?
No.
All right, so what I want you to do, I want you to try this next problem. So you try, so yes, find what mu of x bar is equal to, also find what sigma of x bar is equal to. So take a minute and try to find that. And also, class, remember, for today, you do have your quiz. And remember, covering tomorrow, well, not tomorrow, covering yesterday's lecture. So if you still haven't gone over yesterday's lecture, you do want to go ahead and do that. For that way, you could do good on your quiz. But remember, you have a quiz and it starts at 12 p.m. and you have all the way till 11:59 p.m. to turn in the quiz. All right. So what's my mean for this one?
7.5.
Yeah, 7.5. And then if you look at for standard deviation of x bar, standard deviation you should have gotten it is equal to 1 divided by square root of 16, which is actually just 0.25. All right, and that's it for that one. Any question in regard to the last problem? All right, so up next we're gonna get into finding the probability using the central limit theorem. So finding the probability when you have a sampling distribution, it can be a little bit different. Because if you remember from yesterday we used this formula where we say x minus mean divided by sigma. But in today's lecture, what we had to do, we had to account for the sample size. So since this is for a single data set, so a single data. But for this one, this is when we have n many data. So what we had to do, we had to account for it. So what we had to do, we had to adjust the problem, or we had to adjust the formula. So instead of saying x is for when you have a single data set. If you look at the formula for z, it says x bar. Because since we have a sample size of n many, we don't look at the individual in that n. What we do, we just look at the average of that. So what we want to do, we take the sample mean and you subtract it by the population mean and then divide it by sigma of x bar. But remember, sigma of x bar should equal to this portion over here. All right. Everybody good for that formula? All right, everybody good for that formula. So let's do a problem. All right, so for this one, it says the graph show the length of time people spend driving each day. You randomly select 50 driver aged 15 to 19. What is the probability that the mean time they spend driving each day is between 24.7 and 25.5 minutes? Assume that sigma is equal to 1.5 minutes. All right, so let's go ahead and do this problem. All right, so for this one, first thing you want to go ahead and do, first go ahead and find what's the sample size. So how big of a sample size do we have?
50.
Yeah, 50. So we say n is equal to 50. what do they tell me is the mean time that people commute?
$25.
Yeah, 25 minutes. Okay, if you look at it, since we want to focus on age 15 to 19, 15 to 19 is here, and they spend on average 25 minutes. So we say mu is 25 minutes. All right, and for this one, what's my population standard deviation? All right, guys, come on.
Or
It's right over here.
1.5.
Yeah, if you look at it, it says sigma is equal to 1.5, so it's pretty much just giving it to you, so you have to read these problems. So if you look at it, they give us n is equal to 50, mu is equal to 25, and sigma is equal to 1.5. So if you look at the problem doesn't say we have a normal distribution. So it'll say the problem doesn't say we have a normal distribution. So the problem doesn't say we have a normal distribution. So we need to check our central limit there. So we have to check the CLT. So all we have to do to check the CLT, we only have to check our sample size. So sample size has to be greater than or equal to 30. So if you look at this problem, we said our sample size was equal to 50. So is 50 greater than or equal to 30?
Yes.
Greater than.
Yeah. So since we could say 50 is greater than or equal to 30, we could say by the central limit there, we can say the distribution is normal. Cool. And that's it. Well, technically not it because we still have to find the probability, but that's it on how to check to see if we could say a data set is normal based off of a sample size. So 30 gets a part of the central limit there. So when it says n is greater than or equal to 30, that's pretty much the rule of thumb. But if you go back over here, so if you go back in your notes right here where I stated it, so n has to be greater than or equal to 30 in order for it to be a normal distribution. So you kind of know that is the rule of thumb. So. All right, so let's go ahead and find mu of x bar. And let's go ahead and find sigma of x bar. So if you look at mu of x bar is just equal to 25. But if you look at sigma of x bar will equal to 1.5, but you have to divide that by square root of 50. So I'm going to go ahead and do 1.5 divided by square root of 50. So 1.5 divided by square root of 50. So that would give me 0.2, what do you say, 0.21. All right. Everybody good on how I got 0.21?
Yeah.
All right. So now we're gonna go ahead and we're gonna make our drawing. All right, so in the middle, remember the middle, you always put the mean. So the mean in this case is 25. And if you remember way long ago, they asked us to find the probability that it should be between 24.7 and 25.5. So 24.7, we're going to say it over here. So say 24.7. And then we have 25.5, which we're going to say is over here. And if you look right here, right in front, it says between these two numbers. So if it says between these two numbers, you want to shade this area over here. Everybody good so far with that drawing?
Yeah.
All right. So now in order for us to find the probability, what we're going to do, we're going to use what we learned yesterday. So if you remember yesterday, in order to find the probability of a normal distribution, we use class cal and we use the normal distribution. So if you remember for the normal distribution, it asks us, like, what was the first thing we had to give the normal distribution? What was the first thing it will ask us?
N, right?
Not n.
Oh.
It kind of looked like n.
Mean and standard deviation.
Well, it was the mean. So you first have to give it the mean. So we're gonna say mean is 25. But what was our standard deviation in this case scenario? Well, it's 0.21. So when we go to class cal, we're gonna do normal distribution and we're gonna put that it's from 25 as the mean and our standard deviation is 0.21. So then what was the next step that we wanted to do in class calc in order to find the probability? We had to select something. What did we have to select?
Isn't it CDF?
Yeah, perfect. C, D, F. And then this will pop up. All right, so for this one, what should I put over here on the left-hand side?
24.7.
Perfect, 24.7. And the way he got 24.7 is based off of our drawing. Okay, if you look at it, the lowest part I shaded is 24.7. So what should I put over here for the higher part?
25.
5.5.
Yeah, 25.5. All right, so what I'm gonna go ahead and do, I'm gonna go ahead and transition over to class calc and I'm gonna enter that. All right, so we erase, erase, erase. So we go to stats, we go to distribution, we do normal distribution. So our mean is 25. If you look at standard deviation, it's 0.21. And like Irvin said, we're gonna hit CDF. So for lower bound, we're gonna say 24.7. For the upper bound, we're gonna put 25.5. And then if you wanna look at the picture, you could hit magnifying glass. No. And that's our answer. So you get the probability to be 0.9148. So you get 0.9148, and now we're done with this problem. So if you kind of look at it yesterday, what we learned from yesterday, we're still going to utilize that for today because it's still valid for today. Like the only thing you do have to remember for standard deviation, instead of putting standard deviation, you have to put standard deviation divided by square root of n. Because if you don't, it will give you the wrong answer. Because say if I go back over here, instead of putting 0.21, I put 1.5. Now you're gonna see my answer drastically change. Because now saying it should be 0.2098. So it is very important that you do remember to just change the standard deviation to standard deviation divided by square root of n. All right, so let's go ahead and do the next problem on that lecture. All right, so let's do this next one. So it says the mean room and board expense per year at a 4-year college is 7,540. You randomly select 9 4-year college. What is the probability that the mean room and board is less than 7,800? Assume the room and board expense are normally distributed with a standard deviation of 1,245. Alrighty then. So let's go ahead and get our N, our population mean, and our standard deviation of the population. So what's our sample size? How many college students did they sample?
Nine.
Perfect, 9. So remember, guys, you can also just put it into the chat. So you don't have to open up your mic if you don't want to. You could just put it in the chat. What is my mean? What the mean cost of room and board for this 4-year college?
7,540.
Yeah, perfect. 7,540. And then we have standard deviation. Well, if you look at it, they tell us the standard deviation is 1,245. Cool. All right, so we have the N, which is 9. We have the mean, which is 7,540. And we have standard deviation, which is 1,245. All right, so what do we want to find the probability for?
That it's less than 7,800.
There you go, 7,800. So if you look at it, for probability that X bar, because we want to find what is the probability of those 9 4-year colleges, what's the probability that the mean room and board is less than 7,800? All right, so before we go ahead and start solving this, we have to see if we're able to solve for this problem. So in the problem, does the problem tell us we have a normal distribution?
Yes.
Thank you, Eric. Yeah, so the problem says we have a normal distribution, because if you're able to read, it says right over here, normally distributed. So what we're gonna go ahead and do, now that I know this is normally distributed, I can actually go ahead and solve the problem. Because if this problem wouldn't have told us we have a normal distribution for this case scenario, you actually wouldn't be able to find the probability because our sample size is too low. If you look at the sample size is 9, which doesn't satisfy the condition of the central limit theorem, which says it has to be greater than or equal to 30. So let's find mu of X bar and sigma of X bar. So mu of X bar is equal to mu, which is 7,540. If you look at sigma of X bar is equal to 1,245. But you have to remember to divide this by square root of 9. So if we do 1,245 divided by square root of 9, which is technically 3, you get 415. All right, so if you look at it, we get mu of X bar is equal to 7,540. We get sigma of X bar is equal to 415. And we're gonna use both of those information once we go over to class Cal. So let's go ahead and draw this. So for this one, if you look at it, the middle should be the mean. So the mean is 7,540. If you look at what we're trying to find the probability for, we're trying to find the probability for 7,800. And if you look at it, say we want it to be less than 7,800. Less than means smaller than 7,800. So usually the numbers that are smaller are to the left-hand side. Numbers that are bigger are to the right-hand side. So you want to say this side. All right. So that's my shading. So we're going to use this shading and the mean of X bar and the sigma of X bar to enter it into ClassCalc. So in ClassCalc, you first want to select normal distribution. So once you select normal distribution, you want to select what the mean is. So you should tell it the mean is 7,540. It's also going to ask you for standard deviation. Standard deviation, you should tell it is 415. For this one, since we're trying to find the probability of this occurring, you want to choose CDF. And then this should pop up. So the lower bound, if you look at it, since you keep going to the left-hand side, is going to negative infinity. And if you look at the upper bound is at 7,800. Any question in regard to so far any of those inputs?
No.
All right, so let's go over to ClassCalc and let's just input it for that we could get our answer. And that'll be it for that problem. So you want to go to the keyboard, hit stats, hit distribution, and do a normal distribution. So you do mean. Mean is 7,540. If you do standard deviation, it's 415. So if you want to get a drawing of that, there's the drawing of it. So then you want to hit CDF, and you want to put the lower bound. With the lower bound already negative infinity, so leave that alone. But the upper bound 7,800. Right. So if you look at that, you get that your final answer is 0.7. Is 0.7345. So it's saying if we randomly select 9 colleges, the probability that the average cost of those 9 colleges is less than 7,800, it's telling us there's a 73% chance of that occurring. So they're telling us it's a pretty good chance that the average is either 7,800 or less than that. All right, but that's it for the second problem. Any question in regards to the second problem? All right,
No, sir.
so now what I want you to do, there's a third problem. I want you to do that third problem, and I'm gonna solve it. I'm gonna put some multiple choice answer. And all I want you to do is choose the one that best goes with this. So try doing this next one. So we get A, B, C, and D.
Would 290,600 be the mean?
Yeah, correct.
Thank you.
Yeah, no problem. right, so let me launch this poll. All right, so let's share this. Da, 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 da. All right, so if you look at one person said A, how many people? 3 people said B, and we have 5 people who said C. And then pretty much the rest of the class decided to fall asleep. So for this one, pretty much you want to choose C. C would have been the correct answer. So let's say how we should set it up. So for this one, if you look at mean, is equal to 290,600. So taking the mean of X bar, so you already found what mean of X bar is. So they also tell us standard deviation. Standard deviation of X bar, you should have gotten 36,000 divided by square root of 12. So if you look at the problem they told us that we wanted to be more than 265,000. So in the middle, you put 290,600. On the left-hand side, you put 265,000, and you want to shade the right-hand side because it says more than. Also, a thing that you should pay attention for the problem, if you look at it, it says assume that the sale price for are normally distributed. So that's why you can actually go ahead and find this probability. So if you go to class calc, you want to do normal distribution. You want to select mean as 290,600. Sigma is 36,000 divided by square root of 12. And then do CDF. And the lower bound should be 265,000. And the upper bound should be infinity. And if you enter all of that, you should have gotten a C, which should have given you 0.999 or something like that. But that's it for that last problem. Right. Any question in regards to the last problem?
Wait, yeah. How do you put in the 36,000 over the square root of 12 on class calc? Because I got it, and then it would put like a question mark, like a little. Can you just do that problem like that on class calc, please?
Yeah, so here we put the mean. The mean is 290,600. And then standard deviation, you put 36,000 divided. And then we get the square root symbol. We do square root of 12. And if you look at it, it actually does it for me. So then I'm already here. So you can do 265,000. And then that's infinity. And if you look at it, you get 0.99311, blah, 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 blah.
Okay, thank you.
Yeah, no problem. All right, but that's it for that last problem. Any question in regards to that last problem? All right, so let's do this next problem. So for this next problem, yeah, that's what we're doing. We're doing another one. So right here it says a educational finance corporation claimed that the average credit card debt carried by undergraduate are normally distributed with a mean of 3,173 and a standard deviation of 1,120. So they gave us our mean, 3,173. They gave us our standard deviation, 1,120. So if you look at part A, it says, what is the probability that a randomly selected undergraduate who is a credit card holder has a credit card balance less than 2,700? So if you look at part A, they don't tell you they're selecting like 20 credit card holder or 5 credit card holder. They tell you they're randomly selecting a undergraduate. So for this one, they're actually doing N is equal to 1. So this is going back to what we learned yesterday. So for this one, our sample size is actually just 1. So for this one, for our mean and standard deviation, we don't have to do anything to it because since the sample size is 1. If the sample size was anything other than 1, if it would have been 2, 100, 1,000, a million, you have to adjust your mean and standard deviation. But for this one, since the sample size is 1, you leave it alone. So let's go ahead and draw this out. So the middle should be 3,173. And if you look at it, we want it to be less than 2,700. So here go 2,700, or approximately 2,700. And since it says less than means you shade the left side. All right. Any question in regard to that so far?
No.
Alrighty then. So up next, we're gonna go ahead and figure out how are we gonna enter this into class calc. So before we go to class calc, we're gonna say what are we gonna enter in for class calc. So first you're gonna choose normal distribution, and then what you want to do, you want to tell it what the mean and standard deviation is. So for the mean is 3,173. For the standard deviation is 1,120. So that's what you should enter for the mean and standard deviation. Then what you want to do, since we're finding the probability for this, you want to put that we're doing a CDF. So then this should pop up in your calculator on class calc. So then what you want to do, you want to tell it what the lower bound is. So the lower bound, if you look at it, is over here. It keeps going and going. So it keeps going and going to negative infinity. If you look at the upper bound is over here, because that's the cutoff to the highest value. So you put 2,700. All right, so far, any question in regard to any of those inputs?
I have a question.
Yeah.
For the standard deviation for this one, you didn't divide it or anything?
No, because for this one, since the sample size is 1, you don't divide it, because essentially if you do 1,120 divided by square root of 1, square root of 1 is 1, which would still give you the 1,120.
Okay.
So that way you just leave it alone. So because essentially this is going back to yesterday lecture. So since in yesterday lecture, if pretty much to give us a sample size of 1, you don't adjust your standard deviation. You just leave it as is.
Okay, but for all the other ones, we still have to.
Correct, because once we get to part B, you're gonna see now for part B, we're gonna have to adjust it.
Oh, okay.
All right, so let me go ahead and transition over to class calc, and let me get my answer. All right, so in class calc, we're gonna go to stats, we're gonna go to distribution, and we're gonna say normal distribution. We're gonna say the mean is 3,173. We're gonna say standard deviation 1,120. And then we're gonna select the CDF. So for the CDF, if you wanna see it, is right over there. You wanna put the lower bound, negative infinity. Upper bound is 2,700. So if you look at that, we get 0.3364. And that's your final answer for part A. All right, any question in regard to part A? All right, let's do part B. So for part B, what's gonna happen for part B, we're gonna say that now we do have a sample size. So instead of saying in part A where we only had a sample size of 1, if you look at part B, we're saying you randomly select 25 undergraduates who are credit card holder. What a probability that the mean credit card balance is less than 2,700. So if you look at this one, our N is now 25. So since our N is now 25, we have to find what mu of X bar is equal to and sigma of X bar is equal to. So mu of X bar is still equal to 3,173. But for sigma of X, you want to do 1,120 and you divide that by square root of 25. So I'm gonna go ahead and work that out. So 1,120 divided by square root of 25, and you get 224. So kind of notice the difference between A, where we didn't have to divide by square root of n, and B, where we did have to divide by square root of n. If they tell you we're finding the probability for a sample of n many, you have to divide by that n many. But in part A, since we did it for just one randomly selected person, pretty much you have to divide it by square root of 1, which essentially square root of 1 is 1, so it doesn't affect it. All right. So let me go ahead and use Jack. Cool. All right, so pretty much the drawing should still be the same. So let's enter where we're gonna put once we go to class count. So once we go to class count, we're gonna go normal, distribution, and for this one, the mean is still the same. It's still 3173. Oops. But if you look at the standard deviation, you have to adjust it. So you have to put the 225. So you don't put 1,120 because that would give you the incorrect answer. And then you choose CDF. But any question why we change it from 1,120 to 224?
No, I get it now.
Good.
Yeah.
All right, so then for the lower bound would still be negative infinity, less than or equal to x, which is less than or equal to the upper bound, which is 2,700. So what I'm gonna go now, I'm gonna go back to class count, and technically the only thing I have to change for class count, I only have to change the standard deviation, because instead of putting standard deviation 1,120, we're gonna change that to 224. So let's go to class count. All right, so if you look right here, I'm gonna go right here, change the 1,120 to 224. Make sure I magnify this. And this is our new answer. So our answer for part B is 0.0174. And we're all done with part B. All right, and that's it for B. So for B, we got 0.0174. And if you look at part A, we got 0.3364. So the answer are drastically different. So if you do forget to do the square root of n, it will drastically change your answer and you will get the wrong answer instead of getting the correct answer. All right, so if you look at part C, it says compare these two probabilities. So which one's more likely to occur, part A or part B?
Part A.
Yeah, good. Part A is more likely to. So if you look at part A is more likely to happen. So it's telling you like it's more likely that we randomly select one person and that one person credit card balance is less than 2,700 versus having to randomly select 25 people and for their average credit card balance is less than or equal to 27,000, well, 2,700. All right, but that's it for that problem. Any question in regard to that problem? All right, so let's go ahead and do this next problem. This one should be the last problem. Oh, we actually had 3 more problems. Cool. All right, so for this one said a consumer price analyst claimed that the price for liquid crystal display LCD computer monitor are normally distributed with a mean of 190 and a standard deviation of 48. So right here, mean is 190, standard deviation is 48. So if you look at part A says what is the probability that a randomly selected LCD computer monitor costs less than 200? So for part A, how many LCD computer monitors are we getting?
1.
Yeah, good, 1. So for part A, there's no need to make any adjustments since we're only doing a sample size of 1. You could just pretty much go on to the drawing. So in the middle, we put 190. And if you look at it, we wanted to cost less than 200. So 200 is roughly somewhere over here. So if we want it to be less than 200, we'll shade this side over here. All right, everybody go with that drawing.
Yes.
All right, so once again, we're gonna just put what are we gonna enter into class cal. So we're gonna say normal distribution. We're gonna say mean is 190, sigma is 48. We're gonna select CDF because we wanna find the probability. So for this one, we'll say that the lower bound, if you look at it, since it keeps going and going to the left-hand side, is going to negative infinity. And if you look at the upper bound, it gets cut off at 200. So that's what I'm going to enter in for class count. Any questions so far for that notation?
No, it's good.
All right. So let me go ahead and go to class count and enter this. That way we can get our answer. So we go to stats, we go to distribution, we do normal distribution. So we say mean is 190, we say standard deviation is 48, we close it, and now we go to CDF. So CDF, lower bound is negative infinity. If you look at your upper bound, that's 200. So if you look at that, we get our probability is 0.5825. And that's it for part A. Any question for part A?
No.
All right, so let's do part B now. All right, so if you look at part B, it's B. You randomly select 10 LCD computer monitor. What are the probability that their mean cost is less than 200? So if you look at B, how many computer monitor do we have?
10.
10. So that means n is equal to 10. So since n is something other than 1, we have to now find mu of x bar, which is still 190. And now we have to find sigma of x bar, which it will now be 48 divided by square root of 10. So let's do 48 divided by square root of 10. Oops. 48 divided by square root of 10. You roughly get 15.2. All right, so instead of having to put normal distribution 190 and 48, what we're gonna have to do, we're gonna have to put normal distribution 190, but instead of the 48, you have to put the 15.2 to get to account that we're doing a random sample of 10, not a 1 LCD monitor. So let me go ahead and draw this out. Cool. Cool. All right, so notice for part B, the only thing that I gotta change on what do I enter onto class count is the standard deviation. So instead of having standard deviation of 48, all you have to do is change the 48 and you change it to 15.2. So let me go ahead and just change that to 15.2 in class count, and it's gonna give us our answer. So change this to 15.2. Yeah. And if you like, we get our answer to be 0.7447. All right. And that's it in regard to part B. Any question for part B?
No.
Let's do So for part C, it said compare the two probabilities. So of the two probabilities, which one more likely to occur?
B.
Yeah, B. So we'll say B is more likely to occur. B is, oops, forgot more. Nice, wait. All right. So let's scroll on down. There we go. So we're gonna do this one and we're gonna call it a day. So for the next one, it says a bank auditor claimed that the average credit card debt carried by undergraduate are normally distributed with a mean of 2,870 and a standard deviation of 900. So we got a mean of 2,870, standard deviation of 900. So for part A, it says, what is the probability that a random selected credit card holder had a credit card balance less than 2,500? So here you go, 2870, sorry. Here you go, 2,500. If you look at it, it says less than, then you should the left-hand side. Also, if you note for this one, it says, what is the probability that a randomly selected credit card holder? So it's just one credit card holder and not multiple. So for this one, n is equal to 1. So we don't have to really do anything to it. So let's just enter, what will we enter into class calc? So we'll say normal distribution. And you want to say the mean is 2870. Your standard deviation is 900. Then when you want to go ahead and do, select CDF. And for the CDF, you want to do, select the lower bound. So if you look at the lower bound, that's negative infinity. And if you look at the upper bound, the highest value that we shaded, which is 2,500. So that's what we want to do in class calc. Any questions so far on any of those notation?
No.
All right, so let's go to class calc. So in class calc, we'll change this up. So it's a mean of 2870 and 900. My lower bound still negative infinity. My upper bound will now be 2,500. So if you look at that answer, we get 0.3405. And that's it for A. Any question for A?
No.
Let's do B. All right, so if you look at B, it says you randomly select 25 credit card holder. What are the probability that their mean credit card balance is less than 2,500? So for this one, how many credit card holders did we sample?
25.
25. So that means we have to find mu of x bar and we have to find sigma of x bar. So mu of x bar is still 2870. Sigma of x bar will be 900 divided by square root of 25. So let's do 900 divided by square root of 25. So you get 180. All right, so pretty much what's gonna happen, well, this answer is gonna change, but also instead of putting sigma, we have to put sigma divided by square root of 25. So you have to change this to 180. So when I go back into class calc, the only thing I'm going to do is change sigma into 180, and then that's it. So we'll go ahead and go back to class calc. So instead of putting 900, we'll put 180. And if you look at that, you get your final answer to be 0.0199. All right, so you get 0.0199, and that's our final answer for B. So for this one, for part C, it said compare these two probabilities. So if you look at it, A is more likely to occur versus B because A has a 34% chance of occurring versus B only has roughly like a 2% chance of occurring. And that's it for that last problem. All right. Any question in regards to that last problem? All right. So just remember for this one, we skipped today's lecture and we actually went to Monday's lecture. So what you want to do for the activity, you want to skip this activity. This activity, I'm going to give everybody credit for this activity. And you want to go to the activity that's on for Monday, because since we went over lecture for Monday, you want to do activity that was for Monday. So skip today's activity and just go to the activity for Monday. The one that's for today, you're not going to be able to do it because essentially I didn't give you that information to be able to do that one. All right, but for today's quiz, you're still going to do today's quiz. And remember, today's quiz is going to cover what we went over yesterday. Not what we went over today, but yesterday. So go over your notes for yesterday. For that way, you should pretty much get a perfect on today's quiz. All right. Any questions?
Which activity do we do in 16?
Here, let me look it up. Over here. Here, let me go into the syllabus. The syllabus should say. So today, the 24th. So for today, the 24th, we were supposed to do activity 15, but since we skipped today's lecture and went to Monday's lecture, you want to do activity number. You want to do activity number 16.
Okay, thank you.
Let's see the name of the homework. Let's see homework. So the name of the homework should be under normal distribution. Oh, sorry, this was the homework for yesterday. For the homework for today should be chapter 7. So for chapter 7, and then go right here. So it should be the central limit theorem. So that should be the homework for today. So the central limit theorem. All right. Any other question?
No, that's it. Thank you.
All right, you're welcome. All right, guys. So that's it for today. So I'll see everybody on Monday.
Do we still do 6.3 off of the homework?
Here, let me quickly check that. You're talking about chapter 6, correct, everybody?
Yes, sir.
You said 6.3?
Yes, sir.
6.3 doesn't show for me. Here, let me look. Okay, I got homework on 6.1, homework 6.2.
Oh, that's what I meant. My bad. That's what I meant.
Oh, 6.2?
Yeah.
You should still be able to do 6.2. Yeah, you should be able to do normal and standard distribution. So you should be able to do 6.1, 6.2.
Okay. Just double checking. Thank
Yeah.
you.
No, you're welcome. All right, guys. Have a good weekend. I'll see you on Monday.
Later.
Thank you, you too.